Okay, good morning everyone and welcome to all our friends and colleagues in Indonesia. Welcome to today's webinar on Australian wheat for Asian baking. Some of you, most of you I'd like to think, will remember our in-market workshops on the same subject. And this is really just an extension of some of that work we've done with you over the last 5 or 6 years or before COVID. So it is a little bit different today. We are unfortunately not face-to-face, but are hoping to bring as much interaction to you as we used to when we were visiting. So today's webinar is organized by AGIC. Again, most of you are familiar with us and most of the work that we've done in your market specifically. We are Australia's leading organisation for market insight, innovation and applied solution. So we work together with our grains industry to support you better and of course need to work as closely as possible with you, our customers, to get the best possible experience for you on using Australian grain. The context today, of course, is using Australian wheat in your baking applications. I'm sure I have met most of you, but for those whom I haven't met yet, my name is Larissa Kato. I'm Wheat Quality Technical Markets Manager here at AGIC. Today with me, I've got my team of baking experts, Jason on my right-hand side and Pam on my left. And between the two of them, they've handled, molded and baked most of the samples that we will show you today during the proceedings. We also have a visiting guest, if you like, who again, most of you are familiar with. One of our dear collaborators, colleagues and friends, Stan Cobain, from Baketren, our collaborator from the UK. Has kindly prepared a presentation on using C-cell as a tool for managing the quality of your baked goods. Because of the time difference, we have his presentation pre-recorded and we'll play it for you as part of our one of our presentations today. So in addition to that, we'll have a presentation from us on quality, functionality and applications of our wheat in your baking formulations. We also have what I like to call interactive part of the webinar, or most interactive part perhaps, where we'd like to ask for your input on your views, your opinions on your quality needs for your baking wheat and flour specifically. So we will come to a point in the webinar when we'll take a little bit of a break and kindly invite you to participate in our wheat quality surveys for baking applications. And I'll explain a little bit more about how all that is going to work later towards the end of our first presentation. For now, I can see that some are still joining us. So welcome again to the AGIC's webinar on Australian wheat for Asian baking. Just a little bit on a couple of housekeeping little messages. At the end of the webinar, we have allocated some time for questions and answers. Any comments, any feedback, as always, we appreciate your time in letting us know how we went or how we're going. And please, as I said, it's not quite a live or face-to-face experience, but there are pretty good interactive features of the Zoom that we can utilize today to best experience, I guess, the webinar today. So please use the Q&A tab at any point during today's webinar to ask your questions and or pass your comments to us. And as I said, at the end of the proceedings today, we'll try our best to address all your questions and comments. If you do experience any issues of technical nature in joining the webinar or understanding, seeing what we're sharing, please use the chat tab and our IT expert, Luke, in the background should be able to help you out. Also, today's webinar is available in English and also in Bahasa Indonesia. You can choose your preferred language by selecting either Indonesian or English. At the bottom, towards the right-hand side of the screen, there's a little round ball, globe-like looking icon. If you press on it, you'll be able to select between either English or Bahasa Indonesia. And you can switch between the two languages if that's what you'd like to do during the webinar today. So the webinar is being simultaneously translated, and again, if your questions do happen to come in Bahasa, that's not a problem for us. We'll get our translators to help us out there. So with that brief introduction, we might get started with our first presentation, which I'll get us started, and then we'll finish off with Jason talking about some specific applications of our wheat. So my presentation, first of all, is going to just briefly cover quality and functionality of our wheat in general. I'll keep the focus on the types of classes and grades we specifically use or recommend for baking. So we'll stick to high protein, hard grade, milling classes of Australian wheat and talk specifically about baking applications today. Throughout the talk, I'll make a number of references to quality requirements, to the way how we manage quality here, from development of new varieties all the way to commercial production of those varieties, grading, binning and shipping of those varieties in grades or classes to the end destination. So the overall quality management from classification to the supply chain and the outturn to the customers. Just a little bit more, and I hope you can see this better, perhaps to the live little video picture. Two experts who will be supporting the webinar or me today. And as I've mentioned, Pam and Jason have literally handled every single sample that we will be presenting and talking about today. Also, just before we get into the quality of the current season, a little bit about, briefly again, as most of you in Indonesia are fairly familiar with our milling wheat, just touching briefly on the three key, if you like, or main milling classes of our wheat for your baking applications. Starting here with APH, Australian Prime Hard, which, as you know, is the highest protein class in our system. All our milling classes are based on white wheat, so that is a prerequisite for all breeding companies to be breeding and developing only white wheat. That is specifically with a focus on milling, not just the efficiency or yield, but certainly brightness and cleanliness of flour that comes from the use of white wheat. And here with APH, a specific focus is definitely on baking, so from wheat and flour quality, on rheological properties of varieties that breeding companies are developing. Again, a system that our industry applies is balanced dough properties. So yes, we do look for as much strength as we can get in a high, hard grade protein wheat. but at the same time, our system focuses and looks for relatively speaking, decent amount of extensibility. So the balance between the strength and extensibility is one of our focuses at the time varieties are being classified into any given classes. APH typically across Asian markets finds its use in just about any baking applications, I'd say, and then certainly baking of those European style, if you like, high volume breads in particular. Australian hard is segregated at two different protein contents, typically every given season, minimum 11.5 on 11% moisture basis, fairly versatile, but with an again focus on excellent milling quality. So on top of all the other quality traits or barriers, if you like, that breeding companies have to pass, milling and focus on milling efficiency, it's certainly top there for Australian hard as well. Balanced dough properties again, fairly a little bit lesser strength compared to APH, for example, again, given the lower protein, but again, fairly extensible dough is what we are looking for here. A range of different uses, again, baking applications, some pan bread applications, but also different types of rolls, buns, and other baked good products, as well as some premium segment of noodle products, particularly those products requiring stronger or firmer bite in particular. Our APW, we've said here, really a good opportunity for blending options for baking users. It is a lower protein content compared to AH and APH, so therefore not really intended to be used on its own for example, pan bread baking, but certainly versatile, again, good milling quality, clean, bright flour, so good for certainly blending with either much higher protein, stronger wheats, or lower protein or even softer wheats for some perhaps confectionery applications. So again, fairly broad range of uses throughout Southeast Asia across different baked good products or applications. So that's the three classes will focus a lot of our discussion today, showing you examples of the performance of the three main milling classes from different environments in the growing wheat belt of Australia, and also showing you, as I mentioned, some different applications specifically in the context of Southeast Asian baking. Before, just very briefly, for perhaps some of you who are new in the audience, I'd like to just briefly introduce how and what we've got here to generate a lot of information that we do share with you. So our testing facilities are based on small-scale testing. We do not here have anything of a commercial or a pilot-scale bakery, but small scale of testing anything from grain quality to milling, as you can see here on the top photo, a small-scale test mill to understand either how a new variety might perform and might fit into any of our milling classes, or more importantly, to understand what the quality of our crop is in any given season. After milling, really a range of latest tools and technologies is applied here to understand the quality of the flour itself and also rheological properties of that flour, again to help us understand or indicate how that flour might perform in any given baking formulation. And we will be talking about different processes and also different formulations of baking, and showing you how some of our flour and our wheat performs in different process, system and or formulation as well. A lot of focus, particularly by the team here, is on rheological properties of the actual bread dough. So in addition to doing or understanding quality and rheology of flour, we also spend quite a bit of time on focusing on how does the rheology change once we start introducing our typical baking ingredients, salt, sugar, fat, enzymes, emulsifiers, and a range of other things that we might use in any given baking process for any given baked product. So that is really critical for us to understand, not just to understand how our flour might behave in any given context, but also to understand potentially how we manage or manipulate those rheological properties to meet customer targets. And beyond that, of course, the focus is on the quality of the final product. As we know, for a lot of our customers in Indonesian and Southeast Asian context, volume of bread is critical, important to meet, but in addition to that, of course, there's few other quality traits, structure of our crumb, color of our crumb, softness or firmness of our crumb, that all really form the overall quality of our bread. And so we'll be talking about those quality traits in a little bit more detail throughout today's webinar. I'll start off with just a brief summary of our current crop, so still current crop, so 2021 season. We are probably still a couple or few weeks away from really going into our harvest, and with some hopefully dry and sunny weather, we should get in about a few weeks' time. So 2021 harvest season, a summary here in the table, as you can see, of the three main milling classes for baking again: APH from Queensland and New South Wales, AH from WA, South Australia and East Coast, and also then APW from same regions, WA, South Australia and East Coast. So as I mentioned or shown you a few images, here at AGIC we conduct a range of tests from grain quality to test milling to really understand what the potential in any given season of our grades and classes is to be used in Indonesia for baking, of high sugar, perhaps high fat sweet buns, so pandesals in Philippines or banh mi in Vietnam. So to really understand how much can we understand from the flour and rheology to support and advise our customers on how best to use in either which systems or which particular formulations to best use with our wheat. So what we've seen in our 2021 crop, it's fairly, relatively speaking, what we would expect to see from the three classes, differing, as I mentioned before, in their protein content or the segregation of these three classes. So if we look at, for example, water absorption, which we all understand and know very well, it's quite important to our bakers. It's quite important to have that water absorption as high as we can, which basically then will yield more water to more yield, and therefore better profits, of course, for your customers or our bakers at the end of the day. Typically around 64, 65, I would say it's a long-term average for APH. And then probably this number, obviously, of flour quality traits that contribute to water absorption, protein content perhaps being a more significant one. And so what we do tend to see is with a slight drop of that protein, our water absorption, of course, decreases slightly in our subsequent grades of AH and APW, as we can see here. I mentioned balance and importance of balanced rheological properties in our system. And so that's really where we start looking between the farinograph and extensograph information here on the relationship or correlation, if you like, of the door development time, stability, as well as strength and extensibility of that door. And as I've mentioned, we understand very well that for a lot of baking applications, a lot of you might require and be asking for stronger and stronger beads. Our current system has a particular focus on the balance, largely because of the understanding and belief that that is critical for different processing applications. And I'll come to that a little bit later when we talk about potential new classes in our system. But otherwise, in terms of that balance and those rheological properties, again, this is the 2021 season here in terms of strength and extensibility of our three classes here. It's fairly similar to our 5 or 6 year average. Okay, I'll get then straight into baking, and I'll start off here with probably one of the first tests we here would do to understand the quality in any given season. So the test that we apply here, a small test baking test, first of all, is what we call a long fermentation test, so a test that requires the bread dough basically to ferment for a few hours at least, in our case 3 to 4 hours fermentation. So on the left-hand side, we can see the plot or the graph looking at the specific volume, in this case, of different types or grades of our wheat. So APH here, and then a couple of grades from WA, AH and APW, then same AH and APW from South Australia, and same 2 grades from the east coast of our country. Again, there's many quality traits of the flour combined with the process of baking we use that need to be really taken into account when we start talking about quality of wheat or flour for baking applications. Probably the best known, perhaps, or believed to contribute significantly to the volume itself, of course, again, it's the protein content or gluten content in our flour, or wheat and therefore flour. So again, and that's probably what we see here in the long fermentation test, which is widely used in many different countries, in many different classification systems and or crop quality testing systems, to really best discriminate between different samples. But it is probably also a test that highlights the importance of protein content in this case. And so that's exactly what we are seeing here. The higher protein grades, in terms of volume only, tend to perform a little bit better in this particular test than lower protein grades. In addition to volume itself, it's quite critical to understand, of course, how soft or how firm our crumb is. And like for most bread consumers, Southeast Asia isn't different. The softer the crumb, the better experienced by our consumers of our baked products. Again, typically, just on its own, if we look at just the volume and firmness or softness of the crumb as two alone-standing quality traits, we might say or conclude that the firmness or softness of the crumb, it's largely, of course, influenced by the volume. So the higher the volume, typically the softer should our crumb be. However, there are many, as I said, other quality attributes that contribute to that softness And one of those being, of course, the structure of our crumb. How close, how uniform, how fine, or how open and how coarse our cells perhaps might be. So the message, I guess, here is that many quality traits need to be taken into account. Volume might be most critical for a lot of our customers, but we do need to consider a range of other quality contributors to the overall bread quality. Okay, so moving on, as it's important to understand what the quality of our crop is, we here spend a lot of time understanding not just what the quality of our varieties is or our classes in any given season, but also how do we compare to other origins, and particularly in the context of Southeast Asia. Firstly, we understand that for your particularly sponge and dough, long fermentation, long proofing type of systems, your preference seems to be towards the North American crop. And so we understand that very well and use that to understand or broaden our knowledge on what it is really in the North American crop that you value in your processes. But also quite important for us is to understand how do we compete or compare to some of the perhaps newer but incoming competitors that you see in your market specifically. So again, here we are looking at loaf-specific volume. The dark blue bars are grades and again classes of our wheat from different regions compared to some samples from Black Sea region, South America, the yellow bar here, and then North American samples, which we know perform rather well, particularly in the sponge and dough system. So firstly, the team of baking experts here uses this information on Australian crop to understand the variation, to understand where the variation is coming from, and then to work with our breeding companies and with our industry to improve the performance of our wheat, because it's not just you as our customers, but also us as researchers and cereal chemists here at AGIC that we'd like to see as consistent as possible performance of our crop in your baking grists in particular. But basically, there's a range of, as we can see, higher protein crop out of our particularly 2021 season. It's some very good samples, in fact, comparable to the North American example shown here on the right-hand side of the bar, and certainly a significant, from a baking perspective, quality improvement compared to the Black Sea samples. Similar, again, Australian wheat compared to Black Sea, South American and North American crop in terms of bread firmness. Again, you'll remember I've mentioned a second ago, largely related to volume. So the higher the volume, the softer the crumb in theory. And again, you've seen smaller volume on the previous slide for all Black Sea and South American samples, and now higher bars for our crumb softness, which basically indicates firmer crumb. And of course, as bread eaters and consumers, we all like that crumb to be slightly softer for the full mouthfeel experience when consuming our baked products. Maybe not as critical in baked products like it is for noodles for us, but important for the brightness and whiteness of the crumb. We believe it's the color of wheat itself that contributes to the cleaner, lesser contamination from the bran. And when we do have some of the bran, of course, through the process of milling going into flour, the white Australian wheat, the bran being lighter or whiter in color, that reflects in the whiter or brighter crumb of your baked products compared to what most other origins offer, and that is red wheat. So the advantage of the wheat itself in terms of color does contribute to the advantages of the crumb in the baked products as well. On top of that, as I said, milling extraction, of course, and in the context of our benchmarking here, we mill all our samples to about the same extraction rate so that we can actually compare apples and apples rather than be comparing apples to oranges. Probably most pronounced different in color is a little value that probably most of us tend not to use very often, and that's on the objective spectrum of color measurement, the spectrum that actually measures the green to red spectra of the color. So that's our A star on the Minolta color measuring unit. With red wheats or wheats and flour from most origins. For wheat, as you can see, the higher the positive values, so more samples, or all of our crumbs from the Black Sea, South America and Northern American crop has moved into higher positive values on A, indicating darker, brownish, reddish, if you like, appearance of the crumb compared to the fairly neutral. So either values around zero, either a very tiny positive or even in some cases small negative, indicating neutral spectrum of green to red. Again, to the visual or human eye, that's the brighter, cleaner, lighter appearance of our crumb. So this is really only from wheat and flour perspective. At this point in time, in this particular test, there's no other ingredients in our test baking that would interfere with that color. Commercially, of course, we know many ingredients in baking can and might and do interfere or develop different colors. But this is just looking at comparing wheat to wheat and flour to flour in a fairly basic and standard test baking application. I'll now move on just very briefly to give you a bit of an update, as we promised in some of our earlier webinars, on a research project that Pam and Jason are leading here at AGIC. And this research project was implemented and started at the back of our in-market studies with you and understanding how important and critical for you as our customers is a particular term, tolerance to fermentation. So when we visited previously and spoken with a lot of you on the qualities that you require in your baking or milling for your baking customers, we understood how critical it is for you to have a good tolerance in your wheat, i.e. flour, for particularly long fermentation or sponge and dough baking systems. So we've came back with a clear message and implemented a research or technical study to better understand, firstly, what does the term actually mean? How do we define the term tolerance to fermentation in our wheat and flour? And how would we go about objectively measuring and documenting that, firstly for our industry, so that we can communicate to our breeding companies and say, this particular quality trait needs to be understood or needs to be improved. So this range of different quality tests that we've implemented in this particular research or technical study, I'll briefly just explain one, which is using an objective measure of the total production, loss, and therefore retention of the gas during the fermentation process of baking. So here we are using a device called Rio F4, which can be used to understand the function of yeast, can be used to understand the function of other ingredients in baking, can be understood or has been used a lot of times to understand how, as we all, as society, move towards reducing salt in our food, particularly baking, how that reduction of salt, for example, interferes with fermentation of baked products. Here, however, we are again applying a very lean or clean formulation, if you like, with minimum amount of yeast. Of course, we all know gas is produced by yeast, but what we want to see, it's not just how good our yeast is or which type of yeast we need to be using, but how is our flour, or rather gluten in our flour in particular, managing or holding onto the entire gas produced. So in this test, we basically look at two key traits: the development of the dough, which we can broadly define in terms of good or high dough development, medium or moderate, or low or rather poor dough development during that mixing and fermentation time in particular. So on this chart, first of all, if you look at the dough development, again, one of our lines in development, so the lines that currently is yet to be classified perhaps, compared to a sample out of Canadian or North American wheat. So we see, just briefly again, in terms of the dough development itself, the black line being our Canadian example, starts developing, so the gluten starts developing and forming slightly faster compared to the red line being one of our experimental lines, if you like. But we also can see that that development plateaus off sooner compared to the red line. So the red line indicates slightly higher development and slightly higher stability in particular, which we measure at the end of the 3-hour fermentation process in this particular experiment. A second piece of information we receive or look at here in order to better understand this tolerance to fermentation term is the production of gas in terms of how much gas do we produce as a total, but also more importantly, how much do we lose throughout the entire fermentation process, and how fast do we lose that gas. So therefore, at the end of the day, with the amount of gas left, can we relate that to better baking quality in some ways? So what we see here, again, the black line being the North American crop, starts releasing their gas at a slightly faster rate than our red line here, and loses a little bit more gas than our line in development here. I'm not suggesting that this is the answer to baking, full stop, but it is a critical insight for us to correlate that to the content of gluten and protein we have in our wheats, and perhaps more importantly, to the quality of the matrix that gluten develops in our dough, to understand and how that tolerance to fermentation might or might not lead to better baking outcomes. We've also compared the same line to our example from the Black Sea. So what we've seen on the previous slide, it's slightly higher, i.e. better dough development and stability overall by the line 595 compared to the moderate dough development in the Canadian line. And here, as you can see, very much weaker, less stable, plateauing off much quicker by the purple line indicating, showing our Black Sea sample. So if you like, we describe this as a weaker or poorer dough development time compared to the red line and also compared to the Canadian example from the previous slide. And similar again with the Black Sea example in terms of the gas release. a faster release and a greater quantity of gas lost compared to our red or experimental line in Australian wheat. So now, if we just quickly look at the chart here on your right-hand side, which shows the total gas production, the retention of gas, so therefore retention meaning how much of the gas do we have left at the end of the fermentation process, and in our case we use a 3-hour here, and bread volume. So first of all, you'll see that the Canadian sample actually produced the greatest amount of gas. If you look at that, so that's the dark blue line. However, what's important to note is that our line, experimental line, has lost least amount of gas. So if you look at the difference between dark and light blue line, so that's the gas retention by the light blue line, you'll see that in our sample, most of or more of the gas produced has actually been retained. However, what's critical to understand also in this context, as I mentioned a minute ago, the quality of the gluten matrix. So even though we have slightly more gas, so therefore, let's say perhaps in theory, it should have a higher volume of bread, the ability of or strength of that gluten, flexibility of that gluten to maintain and hold that gas in a nice looking symmetrical loaf of bread, it's quite critical. So firstly, we believe, or we think it's pleasing to see that some of our lines in development, relatively speaking, have a similar performance in terms of volume to our target, if you like, here out of North American crop. So in addition to understanding this gas capacity, retention, we are now looking more into tests to stress our gluten a little bit more to really understand what else contributes to these slight differences in terms of volume. Better performance than the Black Sea, as you can see, and comparable, I would say, and pleasing for us to see that we do have varieties in the system coming through that are better for baking for your needs, or comparable to baking to some of the strong, high protein, stable wheats, like what we typically see coming out of the North American crop. So with that, I'll briefly summarize first half of the talk, particularly with the last bit of information we shared here, which is a research now that really has started with your input. It has started with your feedback on what your needs are and where you see quality improvement is required with Australian wheat specifically to address your baking needs. So we very much look on that basis forward to further input from you to better understand where we need to go next with our industry to make sure that the varieties we develop or continue to develop continue to meet your particular needs. Our team of experts here is well positioned to support you in using more and more of Australian wheat, and we'll be more than happy to hear back from you either today through questions and or comments or at any stage after today. Versatility, functionality and quality management of our crop, it is something that our industry stands for and continues to put a lot of effort in. Our classification system is probably one of the strictest on the planet. The focus on milling quality in particular and specific end-use suitability remains the core of our classification system. On top of that, we continue as an industry throughout the entire supply chain invest in the clean, dry and food-safe environment, production environment, if you like, of our grain, destined largely, in case of Australia, for our export markets. So with that, I would now like to maybe catch a little bit of a break And before I do that, introduce us to our next section of today's webinar. And this is certainly for us an opportunity to pause a little bit and ask you for your contribution and your input on your quality requirements, your needs out of any wheat for baking, but specifically Australian wheat for baking applications. So some of you who have worked with us in the past are fairly familiar with the quality surveys that I'm about to introduce. Of course, previously these were face-to-face meetings, a lot of discussions. Today, of course, it's using technology, it's an online experience, but nevertheless, we hope a useful experience for you as well as much as it is for us. The quality surveys are used for one sole purpose only, to improve as much as we can quality of our wheat for the best value to you as users of our wheat. So I'll start with a little summary of what we've learned from you in Indonesian market specifically previously. So this is now going back some maybe 4 or 5 years, or 3 to 4 years before COVID, when we visited and done a lot of these studies with you in the market. We understood which of the many different wheat quality attributes are really critical to you. Understanding that probably all of the attributes listed here are important. We understand that very well. The purpose of today is to update that understanding, to see if the ranking has changed perhaps, or confirm that bread volume, for example, water absorption, gluten content, protein content, dough strength, rheological properties of tolerance to fermentation, as I mentioned earlier, remain to be your critical quality traits every single time when you're considering on which particular wheat do you select any given season for your baking grist. On the basis of the studies we completed in your market previously, we have made the following 3 key recommendations to our industry. To maintain, as a very minimum, to maintain quality of our wheat for your noodle applications, to improve the quality and the functionality of our wheat for your baking needs. Here, specifically, opportunities are to look at, and some of you are familiar with the work we have done at AGIC on exploring baking innovations in terms of processing. But specifically here, we are now closely working with our breeding companies to understand what is possible through better or newer genetics, if you like, in our environment. You have to remember, most of you will understand, of course, on top of what our breeding companies can do in selecting good quality baking genes, our environment, our soil type, of course, it's somewhat different to the North American types of soil and environment. And so that also, of course, plays a role on the quality of the crop that we see here. But AGIC, on the basis of these recommendations, are now leading research in our industry to look at perhaps into new classes of wheat. We call it here perhaps elite baking wheat for Southeast Asian markets, or to look into existing types of wheat we already breed for, so AH or APH, classes that you are familiar with. How do we, together with our breeding companies, of course, improve the functionality in particular of those new varieties? Example, we've seen that a red line I keep referring to is an example of new lines being developed by our breeding company. So how can we anyhow improve the quality of the current grades and classes to address your baking needs? Also, we've heard and learned very clearly from you your needs for soft wheat. out of Australia in particular. And again, our team of researchers here at AGIC leads this research with the rest of our industry. Firstly, in identifying and understanding what your exact quality requirements are, and secondly, documenting that to our industry and working closely with our breeders to make sure the lines they develop fit perfectly your quality needs. We've also listened to your feedback on how more convenient or faster or easier to use you wanted our surveys to be. So what we will offer in about a couple of minutes' time is for you to use just about any device you can imagine, anything from your mobile phone to your tablet, laptop or your desktop to participate in this part of the webinar. The surveys are your view, your opinion on your market and your understanding of your quality needs. So there's no right or wrong answer here. It is about what you believe your market needs for baking in terms of wheat and flour quality or functionality. Surveys are completely confidential. We will share the summary of the entire Indonesian market with you, confirm those results with you before that information is shared with anyone else in our industry. It is quite critical for us to not just complete the survey, but to actually understand what the results mean and whether you as participants in the survey actually agree with the summary at the end of the day, or whether you from your company's perspective perhaps have slightly different view. The surveys are designed and developed by AGIC, but are conducted on behalf of Australian wheat industry. As I mentioned earlier, they are purposely conducted with one sole purpose, and that is to best understand your quality requirements so that we as AGIC and also as Australian industry can serve you better as our clients. So with that, I would like you all to participate. We appreciate your time and your feedback. Surveys, as I said, have been made easier and faster. It shouldn't take us more than 10 to 15 minutes. We will allocate about 15 minutes time in today's program. So we'll pause for a minute, give you 15 minutes time to complete the surveys. We will stay online. So please, if you do experience any issues, if you have a question or two, if you're not quite sure what to do, use the chat Q&A tab, raise your hand. We will be here online to support you throughout the next 10 or 15 minutes. But for now, in your chat tab, you'll see the survey links being shared. You can copy paste from there. You can simply scan the QR code that you can see on the screens right now with your mobile device. You can do the surveys in either English or Bahasa again. Thank you very much for your time and your feedback. Your feedback matters to us and our industry, and we look forward for as many of you as possible participating in these surveys. Let us know if you need help, if you need a hand to get started. Otherwise, we'll pause for a second and let you complete the survey before we continue with the rest of today's program. Thank you all again for your time and your feedback. It is very much appreciated. We will continue with the rest of the program in about 10 minutes time. Thank you. Thank you again very much for your input and your feedback on your quality requirements. We will continue with the rest of the program in about 5 minutes' time. Okay, thank you very much again for your input, feedback on our bid quality surveys. Just a little note, if you have not had time to complete the surveys at this stage, we would like to please ask you to go back and, if you can, please complete them throughout the rest of the day. The surveys will remember where you're up to, so it is not a matter of needing to go from beginning, but you'll be able to pick it up from where you've left it. So if you haven't had time right now, please, we would like to ask you to allocate a few more minutes to our bid quality surveys for your baking requirements. But now it is time for us to move on with the rest of our program. And so our next presentation will be by one of our baking experts, our baking specialist here at AGIC, Jason Swift, who will be talking to you on applications of our wheat classes and wheat grades in some typical Southeast Asian formulations. So some of you, we hope, will be able to see products that we believe are familiar to you and that you often see in your market. So Jason, please, screen is yours.
Thank you very much, Larissa. Good morning, everybody. Thanks for joining us again after taking part in the short survey. In the earlier slides, we discussed some test baking from a standard Australian test using classification and crop inspection. Also, this long fermentation test is known to best discriminate between different wheat grades from different environments. Thus, it is often used to understand the potential of the crop early in the season or soon after harvest. Our interest here is to understand how our wheat might perform in any given Southeast Asian market, e.g. sweet buns in Indonesia, pandesal from the Philippines, or pan bread using a Southeast Asian recipe. This being somewhat different to the Australian baking, which uses fast, high-energy mixing to deliver the dough, and also, quite surprisingly to some of you, has no sugar used. The next series of slides show a few examples of how you might potentially use Australian wheat flour. Remember, due to the differences in formulation and baking methods, no-time dough instead of long fermentation, we might see some differences in the performance of our different grades. Firstly, let's look at two key quality traits of any baked goods, the volume and the softness of the crumb. These are important to all our customers. The samples used here are APH and APW from Western Australia, AH and APW from South Australia, and APH from the East Coast. In this top slide, as expected, the highest volume comes from the APH. But you can see that with this bread system, the performance of the AH and the APW is from both West and South Australia was quite good and not far off from the APH. Here on this next graph, we can see a much more significant difference, with a smaller bar relating to a softer crumb. The APH sample is clearly the softest, followed by the South Australian samples, which in turn are slightly softer than the two WA samples. For a better understanding of the crumb softness or firmness, it is important to also consider crumb structure. We need to understand how uniform, how fine, how open, or how coarse the cells are. This information here supports our texture results on the previous slide. The APH is the best with the greatest number of finer, thinner, more uniform cells per unit area, followed by South Australia and then the Western Australian samples. Moving on to some sweet bun applications now. Here we used AH from Victoria and New South Wales and APW from West Australia and New South Wales. Again, it's important to take into consideration when baking system and recipe used, as well as understanding the wheat and flour quality. The APW from New South Wales and Western Australia both show the greatest volume and the softest crumb. Remember, the smaller graph means softer crumb. With the information on bread cells, we see that the APW New South Wales has slightly more open, coarser crumb and is therefore slightly inferior. The last application I'll discuss today is Australian wheat for making pain de sal. Here we used APW only from Victoria, New South Wales, and 2 samples from WA. Little or no difference in volume, slightly softer crumb in the 2 WA samples, remembering again that the smaller graph shows a better result. The finest and most uniform crumb structure in the APW Victoria sample, the first bar on the graph. So you might argue that overall, when all or most of the quality traits of bread are taken into account, the example one might choose APW Victoria as their preferred choice for pain de sal. The overall value of Australian wheat is a combination of a number of quality traits, from the grain through milling to flour and the end product applications. Thank you very much for listening, and I'll hand you back over to Larissa.
Thank you, Jason, very much for that insight on understanding beyond just the basic test baking information on how potentially we can use some of our wheats in specific applications that are well known to our customers and audience in our Southeast Asian markets. Pam and Jason, of course, are about to get very busy with our harvest being just around the corner, and we certainly look forward to sharing more of this information with you in our coming webinars throughout next year. Please, as I mentioned, we will allocate some time, or have allocated some time, for Q&A session at the end of the last presentation today. Keep asking your questions. Let us know if you've got any comments or any feedback by using your Q&A tab at the bottom of your screens. We will now move on to the recorded presentation by Stan Cobain, who, as I mentioned, I believe most of you in the audience have met, as he has visited your country with ASIC a number of times and actually conducted a number of our in-market hands-on technical baking workshops. Due to the time difference, Stan was not available for the live session, but has kindly contributed some of his time, pre-recorded his presentation. So his talk will be specifically on a particular tool, if you like, called CCEL. It's an image analyzer used to objectively assess the quality, internal quality of our breadcrumb. So basically, as sensory participants in our assessment of bread, or as consumers, what we would do visually by looking at a slice of bread and describing a crumb in terms of uniformity of the cells, number of cells, shape of those cells, thickness of the cell walls, and so on. The CCEL does that objectively. Within, may I say, just a couple of seconds, quantifies literally a number of different quality traits. But we'll let Stan now tell us more about how this particular tool or equipment can be used in your test and or commercial bakeries to manage quality of your baked products.
Thank you for the opportunity to talk about the application of the C-Cell bakery products imaging technology. First, a few words about Baketran itself. We are an independent international consultancy providing a range of support services to millers, bakers, and their suppliers. We work in close collaboration with AGIC in building a strong technical base for identifying the bread-making potential of Australian wheats in Southeast Asia. We have been able to join them on their visits to the region to run technical workshops in Indonesia and the Philippines, and indeed, I've had the pleasure of meeting some of you in person. We were heavily involved in the initial development of C-Cell and have a lot of experience in the application of the technology. C-Cell is a simple to use bakery products imaging system, which comprises a digital camera housed in a specially designed unit. To obtain a photograph, you simply place a slice of the bakery product onto a special tray and slide it into the base of the unit. The software guides you through the processes of setup and the capture of the raw image of the slice. From the captured raw image, the software produces a series of processed digital images and a range of objective measurements of the physical properties of the product slice. The whole process only takes a couple of minutes. The data generated by the C-Cell software have a wide range of applications related to the manufacture of bakery products, some of which we will talk about today. Within the C-Cell cabinet, there are two different lighting systems. The basic C-Cell is based on a light path designed to highlight the contrast between the little holes in the crumb product slice. We call these the cells. This lighting path simulates the approach used by experts when judging the physical structure of bakery products. The C-Cell color system captures both monochrome and color images and increases the number and range of values which are measured. The C-Cell color system captures over 50 different parameters associated with the product slice. These include information on the size and shape of the slice, as shown by the colored regions in the processed image on the top left. We can see information on the degree to which the sidewalls on pan breads may deviate from straightness, and these are shown in green. Many of the C-Cell parameters are related to the sizes, dimensions, and distribution of the cells in the product slice. In the processed image on the bottom left, each of the cells in the slice has been identified. The darker the blue color, the smaller the cells. As well as the cells, the properties of the crumb surrounding the cells can be measured. We call this the cell wall material. In addition to information on the cells and cell wall material, we can obtain information on crumb color and brightness, and crust color and thickness. There is a lot of information gathered by C-Cell, and with so much data, it is common to ask, how do you know which properties to choose for an analysis? The simple answer is that your choice of properties depends on your needs and the questions you wish to answer. I have listed some basic headings on this slide, and I will look briefly at a few of them in more detail in the following illustrations. C-cell data can be used for everything from the evaluation of new wheat varieties in test baking through the impact of different flour qualities into the bakery, where recipe and process changes can also be evaluated. In a research and development context, C-cell can be integrated with other ingredient and process analytical data to better understand the contribution of dough development to bread cell structure. And this was one of the unique outputs from our collaboration with AGIC. Having introduced the equipment, let's consider a few examples to see how we can use C-cell. Our first example is one very relevant to us today, and that is the evaluation of the bread making potential of Australian wheat types. From the 50+ parameters, we would typically choose to work with between 5 and 10. To keep things simple today, I will use 5, all of which we know from previous experience are relevant to our area of interest. I have chosen slice height, though with bread not baked in a pan, we might use slice area instead. I've chosen the number of cells divided by the slice area so that we can separate out the effects of different slice heights. I've chosen the average cell diameter and the crumb brightness, because with white bread, the brightness of the crumb is very relevant to consumers. And finally, I've chosen the crumb color as represented by the CIE L-star value. On the illustration, I have included a comment as to why each of the parameters was chosen, but I don't have time today to discuss the detail. In this illustration, the maximum heights of individual Australian wheat types are shown in different colors. Multiple samples with the same color, such as the first 7 samples on the left in the histogram, are for the same type of wheat, but from different regions within Australia. As you can see, there is quite a variation in height, but then we would expect that, because not all of the wheat types tested are destined for bread making. Differentiating between wheat types on the basis of loaf height is easy, but that is not the only property that we look for in bread making. The picture is more complicated when we try to use the 5 measures of bread quality that I identified a few moments ago. The data I've chosen are shown in the table bottom left, and just above the table is our assessment of what would be important to us in bread quality terms. I have simplified our task by concentrating on the 7 samples of the AH1 type wheat. For this example, we are using a simple ranking process based on the sum of points allocated to each bread property. It's important to emphasize that all of the samples that we are considering would make acceptable bread, and the differences in bread quality between them is small. Nevertheless, with C-cell, we are still able to quantify the differences, and in this example, understand why the sample coded GER is at the bottom of the rank. And this is because the bread cell structure for this particular sample is poor, despite its high volume. We can also use the ranking approach to compare the bread making potential of new wheat varieties. In this case, we will have a standard target against which to compare any new variety. And that is given by the first bar on the histogram on the left of each chart. In the histogram on the left, we can see that for maximum slice height alone, several of the new varieties give larger bread than the target. I've highlighted one of these samples in yellow so that we can consider other properties than slice height. While sample E would have been ranked higher than the standard for bread height, when we consider all 5 different properties together, we can see, as shown in the right-hand graph, that it falls some way down the ranking order for overall bread quality. I should emphasize that many of the varieties included in this evaluation would individually meet the criteria for bread making. What we are looking at is a within type comparison. In the mill or at the bakery, we may want to see whether a particular flour meets our requirements for bread quality. In this example, we're looking at 3 different flours used in a no-time dough making process. The differences in loaf heights are self-evident, and the chances are that we would not choose to use the sample designated NTD1. Sample NTD2 is closer to height to NTD3 and has similar cell sizes and properties. It does, however, have the lowest value for crumb brightness and highest value for non-uniformity. And we are able to relate these differences to the flour properties. In the case of brightness, to the ash level in the flour, and in the case of non-uniformity, to differences in gluten quality. The behavior of doughs during processing is strongly influenced by their rheological properties. And this affects the uniformity of the crumb structure and the alignment of cells during molding. As shown in this illustration, C-cell can provide much process information of practical value to the baker by quantifying these properties. The processed image on the left identifies areas of coarse cell structure in pink and fine cell structure in blue. Within our research studies with Australian wheat, we have used some innovative approaches to link dough mixing properties directly to bread crumb cell structure. 2 examples are shown in this illustration. On the left, we can see how the numbers of cells that we create in the breadcrumb is affected by increasing the degree of mixing as we move from left to right. In the right-hand illustration, we can see how the thickness of the crumb cell wall changes for the same mixing conditions and gets progressively thinner. These structural changes are important because they affect crumb softness and eating quality, which are 2 very important properties for consumers. In conclusion, we can see from this brief summary that C-cell provides a very powerful and practical tool, which can be applied in many different ways in baking, extending from the evaluation of new wheat varieties through mill and bakery process control, all the way through to the product as seen by the consumer. The key to understanding and using C-cell data is to know at the start what questions you want to answer so that you can select the most appropriate set of parameters to consider. And this makes it a very practical and versatile piece of equipment. I hope that this short presentation has given you a better understanding of C-cell and its potential applications. Thank you for your time and your attention.
Okay, so we do hope that you've got a little bit more insight now into C-cell in particular, and perhaps how to use it in your context better. That's small-scale test baking, like us here at AGIC, or commercial baking for that matter, and to, I guess, have an objective way of managing the quality of your products, particularly products coming out of the oven. As I've mentioned, unfortunately, due to the time difference, Stan is not here in our panel session now, but please feel free to ask questions related to his presentation and CSEL. Our team will do the best we can to address those questions right now, if we can, but also by all means, we will always pass those on to Stan, and he either directly or via us will be in touch to provide you with a more detailed, perhaps, answer or subsequent examples. So again, please, we've got a few questions which we'll start with our little panel session now at the end, but continue to use your Q&A tab to ask those questions. Now it's probably the time to do so before we close off for today. So a couple of questions of general nature on the information or the material we've presented here today being made available to you. So very similar process, or same process rather, to what we've used in our previous webinars. Today's session has been recorded, and in about this time next week we will share the recorded version of this webinar with all of you. So yes, you will have all the material and basically all discussion from today emailed to you, to all of you who have registered for today's webinar. This information will be provided and will be available. If there's anything further, anything extra, we've presented a snapshot of information. We've focused on some of the milling classes of our wheat, specifically for baking. If you need more examples, if you need more detailed information on wheat quality, milling efficiency, flour quality, rheology, baking itself, more than happy to provide that information as well. So please feel free to get in contact with any of us at any stage, and we'll be able to provide information that we hope will be of help and use to you. So I might now throw perhaps first of your questions to Pam, and that's just to address, so when Jason presented on different applications, Pam, of Australian meat in the context of some typical Southeast Asian baked products, what do we mean by typical formulations? How is that different, for example, to what we see on the market here?
As Jason started in his presentation, he started mentioning how the application of the baking in the Southeast Asia market. So as we worked with you over the years, we came to understand your bread system, in particular your formulations used to make different breads such as pandesal, sweet bread, and pan bread, which is different to what we see in Australian market, where sugar is not particularly used, it's something not common. So our role at AGIC, we work to understand how particular Australian grade perform in high sugar systems, and go back to breeders to advise them how to select genes which meet the requirement to perform best in high sugar formulations.
So, Jason, I guess in that context, what do we know about, not just about sugar as such and the bread making and fermentation process, but particularly in some cases, like perhaps your pandesal example, where we understand that sugar content was really extremely high.
Very, very high sugar levels. So we were looking at sugar levels around the 25% mark. which is phenomenally high compared to any sort of standard recipe we use over here in Australia. When we start seeing sugar levels above 8%, it starts to have negative effects on the yeast initially. So it would start to kill yeast off, or at least retards the fermentation process. So you need to look at initially adjusting yeast levels, and then maybe changing the type or species of yeast that you're using to become more sugar resistant. Throughout the mixing process and proving and fermentation, the fermentation rate is sped up massively by this large amount of sugar with a new yeast strain. This in turn puts the structure under great stress. The gluten starts to expand at a faster rate to try and contain the gas. If this becomes too quick, the structure starts to lose the gas, the product becomes porous, and in the end you get very rapid collapse of the dough. So we have to try and manage the rate of expansion, the rate of fermentation, and this high sugar level, and control that within the gluten network to give us stability rather than become porous and lose all the gas. Again, the sugar levels of 25% are huge compared to what we might use as maybe 3 or 4% sugar in what we would class as a sweet bun recipe. So yeah, it is initially a challenge to be able to meet that.
It also sounds that while we do all the quality testing from grain to milling to flour, at the end of the day, we still really need to apply a given formulation application to actually understand how flour might perform.
The flour, the same type of flour will always perform differently. With the slightest change of formulation, the slightest change of recipe, the slightest change of your production methods. So it has to be looked at every step of the way to ensure that you're still in control and still understand what is occurring throughout the process.
So there's no such a way as shortcuts when it comes to quality testing?
No shortcuts at all, unfortunately. Step by step, careful monitoring, careful recording of results, and then the results need to be analysed. There is no point having a massive store of results if you don't understand what they mean, what they relate to, and why they change over time.
And particularly also coming back to the system or baking process, some of our research, in particular with the Indonesian market over the years, has been to really understand and provide evidence, I guess, to our industry on how different types of wheat in our system perform actually differently in a no-time dough system versus long fermentation system versus sponge and dough system. And while we've spent a lot of time to understand those systems, I think we keep coming back to the conclusions that every wheat, every single variety, grade, class, will always perform differently in different systems. Hence, the need to understand the system itself, the interaction, I guess, of the quality or genetics of varieties and classes, how it interferes with the system, and therefore advise, I guess, APW in X system versus AH, for example, in a different baking application, perhaps.
Yeah, sometimes the different grades of flour will perform very slightly unexpectedly in different systems, and where you expect an APH to perform well, it might not perform as well as an AH or APW when you're using one of the sweet bun type systems with a shorter fermentation or a longer fermentation time. And again, this is all about taking those results and analysing the results carefully so you can understand what the causes are of the changes. And
it's very sure for one that very soon we will have plenty of baking results again with our harvest just around the corner.
Plenty of samples to come. Looking forward to it.
Yeah. Good.
It'll be my first harvest with the company.
Good. Okay, well, thanks for that. Let me just double check our nothing further in our Q&A tab. or a chat tab in terms of questions from you. So perhaps it is the time to once again, first of all, thank you for your time today in listening to us. Thank you for your input to our wheat quality surveys. If, as I mentioned, you didn't quite get to complete them, we would please like to ask you to do that now. Your time and input are certainly very much appreciated. As I've mentioned a couple of times, we are just about to go into another harvest. It is going to be another big harvest for us here in Australia, big crop expected again, and no doubt some good quality of the crop as well for a range of the products across many of our markets. So with that, we will probably pause with our webinars for the harvest, but we do look forward in seeing you again early next year with a series of our webinars. Before we sign off, please, one last little very quick poll, a couple of minutes just to give us feedback on how today was for you. What was your experience of today? Again, it is information we use to improve our performance in our future webinars. Thank you very much for your time. Take care, stay well with your companies, with your businesses, and of course with your families as well. We look forward to seeing you soon again. Thank you.
Thank you very much for your time. Hope to see you in the market soon.